Coding is nothing but conversion of that design structure into some programming language. 3 types of maintenance we have in a maintenance phase, that includes corrective maintenance, perfective maintenance and adaptive maintenance. Evolutionary in the sense what? Changes is taking place frequently. That is what? Evolutionary model. The system must be able to adapt to the different environment, different operating system, different computer system. So that is adaptive maintenance. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of B.C.A 6th semester subject called Software Engineering. In short, it is SE, and we are in the unit 1 of Software Engineering. So today we are going to discuss about this life cycle models. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into today's session, that with respect to this life cycle models, we'll just have a quick recap of my previous session. So in my previous session, we had discussed regarding what you mean by software, right? So software is a set of program which will going to be used or which will going to be written to perform a particular task. And also we got to know regarding what do you mean by software engineering. So that is what? It's a discipline, it's an art, it's a management of a software in order to solve a particular problem. So it will going to be organized one systematic way of representing a solution for a given problem. That is what I have discussed regarding the introduction part of this unit, and also we had discussed regarding what are the dual nature of software. So software will going to act as a product, and also it will going to act as a vehicle for delivering that product. That is what dual nature of the software. And also we have discussed regarding the objectives of software engineering. So maintainability, adaptability, testability, scalability, all those ability of a software engineering that we have discussed in the objectives part. So, in our today's session, we'll see what are the strategies we have in order to implement that solution. So, as we all know that we have a different kind of solution or a different way of finding a solution for a particular problem. So, that problem discussion and its solution needs to be with different strategies, which will going to be more reasonable or which will going to be more reliable. Out of that, we have to choose one solution in order to get a solution for a given problem. That is what regarding the software engineering paradigms. And also in order to implement all these solutions, we are going to have a different kinds of models. That is what regarding life cycle models. So in this we have a number of life cycle models. Under that, in our today's session, we'll see about the waterfall model. Okay, this is regarding waterfall model, and also we have an incremental model. As we all know that every model or any of the thing will going to have both advantage as well as the disadvantage. So in order to overcome the previous model or a previous methodology, we are going to have one more model in order to just overcome the disadvantages of the previous one. So in our today's session, we'll see about what is this waterfall model is all about and what is its advantage, what is the disadvantage, along with its application, along with the incremental model. Let me get into today's session, that is regarding software engineering paradigms. As I discussed in the recap, we already know what a software engineering is all about, right? So it is just a discipline, it's an art in order to manage the software in order to get a solution. So then, what are the strategies we are going to use in order to find a solution for a particular problem? That's all regarding this software paradigm. This will going to be software development paradigm helps the developer to select a strategy to develop the software. It is just giving a methodologies. It will going to have a set of tools and techniques, methodologies, everything will going to be included together. So that we are calling that as a software paradigms, and also this will going to help the developer in order to develop a best strategic way of finding a solution for a given problem. And also the software development paradigm has its own set of tools, methods as well as the procedure. So in order to find a solution for any of the problem, it must be reliable and it must be it has to be implemented within a given time and within a given budget. So planning of a solution of that system needs to be well mannered, so that it will going to have a collection of tools, methods, procedure, and also this will going to help in order to find a best solution with the help of some of the strategies, and also which are expressed clearly and defines the software development life cycle. What we have here? So in order to define this life cycle, for example, as I discussed already, we have a different way of finding a solution for a same problem. So out of that, we have to select the best strategy in order to develop the software which will be more reliable. The response time should be less. That means accessibility and its fetching of a content from a software needs to be very fast. So that in order to define all those things, we are going to have this software engineering paradigm in order to implement this life cycle model, and each life cycle model will going to have its own advantage as well as the disadvantage. So before getting into the life cycle, it is necessary to understand if I wanted to develop any solution for a given problem, it has to come across some of the stages of development of a life cycle. That is what regarding software or system development life cycle. So here you can see this diagrammatic representation. So out of this only you can understand what is the first stage it includes, that is regarding requirement analysis. First I must know what is the problem is all about. Then only it will be easy for me to collect the content with respect to that problem. So that requirement analysis will going to help us in order to get the content or in order to get to know what problem is all about. That is regarding requirement analysis. So if I got to know regarding what problem is all about, after finding a solution, that means how to represent that. So for that reason, we are going to have a designing. So here I am going to have some documentation related to a problem. So that documentation will going to be converted into some scheme or representation of a solution in terms of diagrammatic representation. That is what we have in a design part. So now it got designed, I know what problem is all about. So then how to find a solution? With the help of some programming language that needs to be implemented. So that is the another stage, implementation. So in this implementation, by making use of some of the programming languages, they are going to implement a design solution to a given problem. So now I have implemented everything. Now I wanted to check whether it satisfies the requirements of a customer or not. So if you are not able to satisfy the requirement of a customer by implementing any of the software, it is of no use. So we have to test as per the requirement, whatever we have analyzed in the first stage. So testing is also important. So even testing got okay and all the types of testing is over. So now it's time for the deployment of that project or a model to the user system. So evolution in the sense what? Maintenance. For example, after certain times user may feel that I wanted to have one more feature or I wanted to remove the content which were already developed. So evolution in the sense what? Maintenance. So all these stages will going to be included in all the life cycle model. But the way of representing all these life cycle stages will be different from one life cycle model to another life cycle model. So SDLC, system or software development life cycle model. First we have to analyze, that needs to be designed. Then after the designing, implementation has to take place. Once it is implemented, that needs to be tested. If it is okay, deployment has to take place. If it is deployed to the customer location, then the maintenance or evolution of that software is mandatory. So it will be a lifetime stage. So evolution in the sense what? It should not be a static one. Why? Because if all the products or any of the software is static, then we can't expect more from that kind of software. So it has to be dynamic in nature. So then only we can add some more content to the any of the developed life cycle model. So now we'll see the first model with respect to the life cycle model, that is regarding waterfall model. So mainly we are calling this as a classical waterfall model. So as the name indicates, waterfall, how it will be, right? Will it be in reverse order? No, right? Okay, so it will be like step-by-step procedure and it will be top-to-down approach, and what the stages can't be overlapped. Same thing will going to be happen with this waterfall model. So when it comes to the classical waterfall model, as of now we are not using it much. So why? Because we'll tell you here. So this model is the basic software development life cycle model. So this model will be considered as what? Basic software life cycle development model. So this will going to access what model for all the kinds of model. So that is what classical waterfall model. It's like a basement for all other types of life cycle models. And also it is very simple, but it is also idealistic. As of now, we are not using it much. Why? Because I will tell you what is its advantage along with its disadvantage. Then you will get to know for what reason we are not using it much. And also, all other kinds of software development lifecycle model will going to be rely on this classical waterfall model. So here you can see that it will going to divide the life cycle into set of phases. So already we know what life cycle comprises of: requirement analysis, design, implementation, testing, evolution. All those are the stages. All those stages in the waterfall model will going to be divided into number of phases, and each phases will going to be carried out in each stage. So this will going to be considered that as a one phase can be started only after the completion of a previous phase. So how waterfall will be like, it will going to be like this. So if it is completing the reaching this position, then only it can reach to another position. So overlapping of that phases should not take place in the waterfall model, so that the complete whatever the model we have or whatever the content we have, that will going to be divided into number of phases, and each phase will going to carry out its own activities. And also, if one phase is completed, then only we can reach to the next phase. That is what in the classical waterfall model. And also the output of one phase will be the input for the next phase. So output of one phase will be the input for next phase. For example, it will be like this. Consider this is one phase, this is another phase, right? So if I'm done with this phase, then only I can reach to next phase, and whatever the output that I got in the first phase will be the input for this phase. This will be of what? Unidirectional model. And also the development process can be considered as a sequential flow in the waterfall. It will be sequential, one by one. So if one stage got over or phase got over, then only I can reach to the next phase, otherwise it is not possible. So that phases do not overlap. So we can't overlap the phases. For example, here it has to be like this. I can't take in this manner. It can't be overlapped. So here you can see the diagrammatic representation of a waterfall model, so it will be easy for you to understand. So it will be like waterfall only, right? So all the phases are different from one phase to another phase. If I wanted to reach this phase, then I have to complete this phase first, then only I can reach to this phase. And all the phases are independent to each other. So all those will not going to be overlap together. What is the first stage we have? That is feasibility study. So in this we are going to think about whether it is feasible to implement or not. Let me discuss each phase independently. So as of now, you just understand feasibility study. After studying whether it is possible to implement or not, if not, then that will going to be leave there itself. If it is yes, then requirements will going to be analyzed and it will be specified in the documentation form. So here we got to know what user problem is all about and what they are seeking for. After that, documentation that needs to be designed. So that will take place in the design phase, and coding and unit testing. So once it got designed, the implementation of the solution has to be takes place in the terms of coding. So in this coding, we are going to use some of the programming language in order to implement that. Then we have a unit testing. So each phase or models will going to be test independently. After that, it will going to be integrated together. Everything will be merged together as a system. Then that is also going to be tested. So if it is okay, then it will come to the deployment. After that, maintenance phase will be very mandatory. So you can see here, by just looking into this diagrammatic representation of a waterfall model, you can only understand what this is all about. So here, do we have any feedback path here? If I missed anything in the coding phase and unit testing phase, I can't go back to this one, or I can't go back to the previous phase. Why? Because it is all of unidirectional. We can't overlap the phases and we can't go back to the phases. Then only we can use this waterfall model. So this kind of model is only suitable for the smaller kind of products or a projects, and also we can go with this waterfall model only when the requirements are starting. For example, if I am building this bungalow, so I am not at all going to renovate anything. Whatever we are building right now, it will be the same thing for the lifetime. That means if I don't wanted to change any of the requirements, or if I don't wanted to add or delete any of the content, then only we have to go with this waterfall model. This is regarding all the stages. So now we'll see each stage one by one. So first is regarding feasibility study. So in this, problem will going to be analyzed in the terms of money as well as in the time as well as per the technical related thing. Both user as well as the company has to think whether are we beneficial by implementing this model or project or not. So if it is yes, then how much time it will going to require, what is the benefit of implementing this model, whether it is related to technically feasible, whether it is possible to implement it technically, all those needs to be think or it needs to be analyzed by the user as well as by the developer of this particular software. So first they have to think whether it is possible to implement or not. If yes, then how much time and what is the budget. So that is what feasibility study. So this will going to involve understanding the problem and then determines the various possible strategies to solve a problem. First I will get to know what problem is all about. Then after that, what are the different kinds of feasibility study we have, or what are the different strategies we have in order to solve that problem will going to be studied and analyzed in the feasibility study. So now we got to know what problem is all about, but in depth I wanted to know about the problem. So for that we have a requirement analysis. So in this requirement analysis and the specification will going to help us in order to understand the exact requirements of the customer and document them properly. Why? Because documentation is also important. If another user come up with the same problem, then no need to do that project again. Because why? Because once it is documented in a well manner, then it will be easy for us to do the same thing again without doing it from scratch. So that in the requirement analysis and specification, all the problem will going to be understood in a depth manner, so that we will get to know what this exact customer is looking for. What is the exact requirement of a customer? And also this phase will going to have a two different activities. What is that? First we have to find the requirement gathering and analysis. So after getting know the exact requirement of a customer, it's a developer duty to collect the requirement from the different sources. So that needs to be analyzed in a well manner. So once it got analyzed, that needs to be documented in the form of SRS, that is also considered as what? Specification requirements document. So in this, all the kinds of solution or strategy in order to solve that problem will going to be documented together. So first requirement will be gathered from the different sources and that has to be analyzed. Once it is analyzed, that needs to be documented. So that will be considered as what? Requirement specification, that is system requirement specification. So after this, we're going to help as a contract between the development team as well as the customer. It's like a bond. So it will going to be tell us it's a bond or a kind of contract between the developer as well as the customer. They will going to say that yes, okay, we will implement your model, and even customer is also I'm okay with my requirements. That is what in the requirement analysis as well as the specification. So now I got to know regarding everything. Then designing of that solution will be important. So that in the designing team or in the designing phase, the transformation of a requirement specified in the SRS document into a structure. So we have to find a structure or way of representing that documented requirement in the pictorial form, so that it will be well suited for the implementation in some programming language. If I get to know, for example, if you wanted to build any of the house, first we are going to have a blueprint, right? So where the door must be and what number of rooms we require. So that and all we are going to develop or to be designed. So once it is got designed, then it will be easy for the implementation. It's like a blueprint only. So after that, we have to take a phase of coding. Coding is nothing but conversion of that design structure into some programming language. That is regarding coding. So design is transferred into source code using any suitable programming language. So they have implemented or they started developing the product or a project of a phase by phase. So in that, each modules will going to be designed and it will going to be coded. For example, you just imagine my project consists of 5 modules. First, I am going to develop a module 1, then module 2, then module 3. So each module will going to be tested independently. So if you are testing each module independently, then we are going to call that as a unit testing. Each unit or model will going to be tested independently. If it is true, then it will going to be integrated together. For example, M1, M2, M3, we have 3 models. First, I am going to check model 1. If it is okay, then I will go with model 2, model 3. So, if all are working fine independently, then I will check what if I assemble all the models together and how it will going to work. That is regarding integration and system testing. So, in the integration of a different modules are undertaken soon after they have been coded and unit tested. So, if all the modules has been coded along with each module will going to be tested independently, then integration of that modules will be important, so that all the modules will going to have been successfully integrated as well as tested. So, there we are going to check the full working system, that is regarding system testing, and also we are going to obtain that system carried out on this stage. So, each module will going to be coded and tested independently. After that, they will merge together. Will it working fine? If there is an interoperability between the modules and all, if it is yes, then complete overall project or a system testing will going to takes place in this particular phase. And also we have 3 kinds of testing. One is alpha testing, beta testing, and also we have a acceptance testing. So this alpha testing, that means once the system got developed, it will going to be checked or it will going to be tested by the development team. Development team will going to check whether system is working properly or not. So if it is okay, alpha testing got over, then it will given to the customer in order to check the performance of a system, that is beta testing. So even beta testing got over, if customer is satisfied, then that released product or a developed product will going to be given for the actual customer. So that is regarding acceptance testing. So integrated over and we have tested this system. So now it's time for the maintenance. So after the testing, customer accepted that software, so that got deployed in their environment. So after the deployment, they will start working towards to that they will get the benefit of that developed system. So then maintenance is also like a lifetime process. So that maintenance will be considered as a most important phase. Out of 100%, 60% will be given to this maintenance than the design or implementation. All those other phases will going to be completed within a 40%, but this maintenance will be like 60% of a life cycle. So that there are 3 types of maintenance we have in a maintenance phase, that includes corrective maintenance, perfective maintenance, and adaptive maintenance. So when it comes to the corrective maintenance, there they will check for the errors which we can't find out during the development of a models. For example, we are building some house or some bungalows and all, right? So after building that, we may feel that this is not so okay. So this we couldn't find at the time of its development, but that can be maintained and that can be corrected in the corrective maintenance. So that this type of maintenance is carried out to correct the errors. So we did some mistake while developing that system, but it's time to correct that. That will going to be considered as what? Corrective maintenance. So those kind of errors were not discovered during the product development phase. So now they have corrected some of the errors. So now it's fine to use that product again without any errors now. So now what is this perfective maintenance? After some times, human feels that I wanted to add some more content, I wanted to change the existing content. So as of now, what we have to do, so that will be takes place in the perfective maintenance. So this type of maintenance is carried out to enhance the functionality of the system based on the customer requirements. As per the requirement of a customer, the features will going to be enhanced. We are going to have some utilities, right, in order to improve the existing system. That kind of maintenance will be considered as what? Perfective maintenance. So at last we have a adaptive maintenance. So in this adaptive maintenance, the system must be able to adapt to the different environment, different operating system, different computer systems. So that is adaptive maintenance. This will going to be usually required for putting the software to work in a new environment. For example, if you are using WhatsApp in your system or in your mobile, then when you change your mobile from one phone or to another mobile. At the time also, the WhatsApp or whatever the social medias and all the applications whatever you are using in the previous mobile, in the same way that has to be worked in the another phone also. That is what regarding adaptive maintenance. So these are all the phases what we have in the waterfall model. And here you can see what are the advantages. By getting to know all the phases, then it will be easy for to tell what are the advantages we have in the waterfall model. So that it's an idealistic model. All other models will going to be rely on this, and it is very simple and easy to understand because it's a phase by phase. I can't overlap the phase and we can't go back to the previous phase once it is done. If I wanted to go to the next phase, previous phase should be completely done. All those are the advantages, and also each stage in the model is clearly defined, and phases in this model are processed one at a time. So we are going to get more time to give a more importance to each phase, and also very clear and well understood milestones for the development of any of the solution with respect to the waterfall model, and process, actions and results are very well documented with the help of SRS. So in the analysis it will be easy, and this will going to reinforces the good habits like define before design and design before code. Why? Because previous content whatever we are giving, that will be considered as an output for the next phase. So somehow it is a good habit to develop a good model. Why? Because we are going to define before the design and we are going to design before the coding. So that is what somehow considered as an advantage, and also this model will going to work for a smaller project. So if you wanted to have a smaller project and all the requirements are understood, you don't want it to change any of the requirements further, then only you can go with this waterfall model. Though we have some of the disadvantages. What is that? We don't have a feedback path. No feedback path. For example, feel that design part is not over, then I can't go back to the analysis and requirement gathering again. Why? Because it will not going to have a feedback path. So if I am done with the previous phase, then only I can come to the next phase. If I find any mistakes in this particular phase, then I can't go back. That is what no feedback path is there in the waterfall model, that too classical waterfall model, and also somehow it is difficult to accommodate the change request. Why? Because we can't overlap and it will not going to have a feedback path, so it will be difficult and no overlapping of phases. So whenever I'm designing, so parallelly if I wanted to code that, that is not possible in the waterfall model. So in order to overcome all these disadvantages, we have one more kind of waterfall model, that is iterative waterfall model. So there is a small difference between classical as well as the iterative. So in the classical waterfall model, we don't have a feedback path. That means I can't go back to the previous stage if I wanted to do any of the changes. But when we have in the iterative waterfall model, there is a advantage. We have a feedback path. So that apart from requirement gathering to the maintenance, we are going to have a feedback path, not to the requirement gathering or feasibility study. So that iterative waterfall model provides the feedback path. This will going to provide the feedback path, so we can go back to the previous content from every phase to its preceding phases. Whatever the further phases we have, from there we can go back to the previous stages. So which will be considered as a main difference between classical waterfall model as well as the iterative waterfall model. So that feedback path is introduced in this iterative model, and also this feedback path. And why we require this feedback path? Mainly to correct the errors whatever has been done in the previous stage, and also this will going to help in order to make a changes which we require in the previous content, and also it will be helpful detection of an errors in the same phase in which they are committed. For example, in classical waterfall model, even if I find the errors in the previous stage, I can't correct it, but that will going to happen in the iterative kind of waterfall models. So here you can see the different kind of diagrammatic representation of iterative as well as the classical waterfall model. So if it is classical, only we have unidirectional, but in the iterative waterfall model we have a feedback path. So I can go back to each stage once it is designed, implemented or tested. So if I find any errors in this stage, again I can go back to this previous content. Here also it can't be overlapped, and we can go to up to the requirement analysis and specification. I can't go back to the feasibility study stage again. So up to maintenance we can have a feedback path from the requirement analysis and specification. Here also we have some of the advantages. Mainly we have a feedback path, and whatever the advantages we had in a waterfall model, everything comes to this iterative waterfall model also, and somehow it is simple. And also we have some of the drawbacks. What is that? It is difficult to incorporate the change request. Why? Because once in the feasibility study everything got over, then we can't do the changes more time, or frequently we can't do the changes, and it will going to be incremental delivery is not supported. For example, once it is developed, it will not going to reach to the customer. Once completely done, then only it will reach to the customer, and overlapping of phases is not supported. Somehow it's like a classical waterfall model only, but only difference is we have a feedback path in the iterative waterfall model, and also risk handling is not supported. Along with that, we have a limited customer interaction. We won't call the customers again, and we can't think about the feasibility study frequently. Once the requirement is taken from the customer, there will be only limited number of customer and developer interaction. This is regarding iterative waterfall model along with its advantage, then disadvantage. So in order to overcome all these disadvantages, next we have one more life cycle model, that is regarding incremental process model. So as you can see here incremental delivery is not supported in the iterative model, even in the classical waterfall model. So that reason we have one incremental process model. So in this, what we're going to do, so they will just gather the requirements from the customer and they will start working towards to that. So once one model is got over, then that will going to be reached to the customer. So again they will come up with another features, or if they wanted to increment or to add some more features to the existing content, again developer will going to work with that. Then once it got over, immediately that will going to be reached to the customer. It will be like incremental. Maintenance will going to be takes place one after another. So if they are okay with the previous content, then it will be stopped. If they wanted to have one more features, or if they wanted to take some more content to the existing one, that is possible in the incremental process model. So that this is also known as successive version model. Why? Because it's not a static one, it's a dynamic one. If I wanted to add feature, I can add it frequently. That is incremental process model. So that simple working of system is implemented, only a few basic feature which is built and then that is delivered to the customer. It's like a rapid application development. So for example, you just take the example of WhatsApp. They will only work regarding the status, then that part will going to be reached to the customer. Again they will work towards the chat, that model is reached to the customer. Then they will take care about the video call, audio call. So if you see the previous version of a WhatsApp or any of the application software, at the time they are just come up with some features. So once they are getting the requirements of a customer, then they will start working towards to that. That is what happening in the incremental process model. First one model with some basic feature will be developed, that will reach to the customer. Customer will start working towards to that. Once they feel that we want some more features, again it will reach to the developer. Again developer will going to start the development with the help of this incremental process model. This is also considered as evolutionary model, because evolutionary in the sense what? Changes is taking place frequently. That is what evolutionary model. Evolutionary as well as incremental model and successive version of model, all those are the synonyms. When you are getting these kind of question in your examination, you must be able to answer for that. And also thereafter many successive iteration or a version is implemented and it will going to develop to the customer until the desired system is released. So it will going to be released one model at a time. After all the requirement got satisfied, everything will be merged together. It will be considered a system that will reach to the customer as a last product. So here they will come up with a module, then they will work with another module called AB, I can take C again. So then if user come up with any one more feature, then it can be added together. When the number of radius or circumference getting larger, then we can say that more features we have in this incremental process model. And also next we have a life cycle activities. That means in the increment model, what are the activities or what are the actions will going to takes place. So first the requirement of that software will going to be collected together and it will be divided into number of models and can be incrementally constructed and delivered. For example, I will just give a 15 kinds of models. All those 15 kinds of model will going to be developed or will going to be divided into number of sub-model. So they will start working towards each kind of model. Once it is developed, it will going to reach to the customer for the usage. And if any plan is made just for the next increment and not for any kind of long-term plans. So if I am working towards only the number of phases are 3 or modules are 3, then I will worry only about this 3 models and I won't bother about all other phases or all other models what we have in this particular type of implementation. So then testing, all the dedication will be given to the particular problem, and also it will be easier to modify the version as per the need of the customer. Main intention of doing all the life cycle activities is to satisfy the requirement of a customer. So if customer is happy, then developer is also happy, right? So that development team first undertakes to develop the core feature. They will only think about the core feature with the basic feature, then they will start developing towards to that. Once it got developed, that will reach to the customer. That customer will not going to use. So if they come up with new plans, if they wanted to have some more feature, that will going to be added one after another. So once the core features are fully developed, then all these will going to be refined in order to increase the capabilities of a system. So that by adding a new function in the successive version, we can have more efficiency as well as it will be more effective for the usage. So that each successive version of the software is constructed and delivered. So now feedback of that customer is to be taken and these were then incorporated in the next version. So after the successive development of each phase, that will reach to the customer, so that each version of a software have more additional features over the previous one. So why we are calling this as an incremental? Because features are incremented in a frequently manner. So it will be helpful in order to add the more content to the existing software. And also here you can see the process of this incremental model. So first they will collect the requirements and the specification of that requirement will going to be takes place. They will gather all the requirement and in the form of SRS, everything will going to be specified as a document. Instead of considering this as a problem, that will be divided into number of version. So in the version 1, I will design, code, testing, deploy and full software development will going to takes place. And they will feel that I wanted to add some more content to the existing software. Then they will come up with the next version called version 2 and same phase will going to be takes place. It will be like what? Iterative, it will be evolutionary, it will be incremental in nature. So in the same way, number of versions will going to takes place and in each version additional features will going to be takes place, and if you are not okay with the previous content, that is also going to be removed to enhance the performance of a system. So if all the version got over, then we are done with the development of a software fully. So that this is how this incremental model or incremental process model will going to work. And also we have types of incremental model. In that first step, we have a stage delivery model. So that means what? Each part will going to be developed independently, then that construction of only one part of a project at a time. So for example, if you consider here subsystem 1, so already we know that it will not be considered as a single software or a single system. It will be divided into number of sub-modules and each sub-modules will going to be developed only one at a time. For example, if I have 15 sub-modules in my system, all those 15 will going to be developed 15 times. All those 15 sub-modules will be developed independently. Then we can reach to the last level of the construction. So once the construction got over, then verification test will going to take place and also we will be done with validation. So all those stage will going to be like bi-directional. So if I wanted to have some more requirement, then I can go back and I can improve that performance. If I don't like this design, then I can do it again. So all those are the bi-directional, and here only one part of a system or construction of only one part of a module will going to takes place at a time. Somehow it's time consuming, right? Instead of developing each module once, what if I develop 2 submodules together or 3 submodules together? At the time will going to take very less. So for that reason, we have one more type of incremental model, that is regarding parallel development model. So in this parallel development model, you can see that. So here subsystem 1 and up to subsystem n will going to be merged together. So if I wish to have a 2 or 3 development of a models together, I can have it in the parallel development model, so that different subsystems are developed at the same time. This will going to improve the efficiency, and time taken for the development will be low, and cost is also maintained in a well manner. So we are going to have a different number of teams, and each team will going to develop a system from subsystem 1 to subsystem n. For example, you take the example of writing a solution for a model question paper, right? So instead of giving all the model paper solution to a single student, I will just take a teams of 10 students. So in the team of 10 students, I will give 1 marks to a particular student, and I will give 2 marks question to another student, 5 and 10 marks question to number of different students, and together they will start working together. Then I can get the solution at a time. So I can integrate all the solution together. So at last we are going to get the solution for my complex problem. That will be takes place in this parallel development model. So here also we have some of the advantages. What is the main advantage? Error reduction. So why? Because core model will going to be developed first. So they will going to have a basic feature. If something goes wrong in that, then there we are going to have much time in order to correct those errors. So that error reduction will be very high. And also this uses the divide and conquer method. So we are not considering a problem as a complex solution. Instead of that, we will be breaking down all those modules into sub-modules. So development of that sub-modules will be easier. And also it lowers the initial delivery cost. Why? Because they are just giving the core model. So for that, whatever the amount is required, that much they will take. So that it will lower the initial delivery cost, and also incremental resource deployment. So we can have some more additional features to the existing one. This is regarding advantage. Then what are the disadvantages can we expect from this incremental model? So if we are keep on changing, so there might be a chances of losing the interest towards that development of a system, and expensive cost will be high, right? So it requires a good planning and design. So if you don't know how to plan, and if you don't know how to design a solution with some strategies, then it will be a worst case, right? And also total cost is not lower. Why? Because if you are keep on changing the requirements, the time as well as the money whatever we are spending on that will be high. So that well-defined module interfaces are required. So for example, if I am giving one module to the customer for the use, and I am giving one more module to the customer for use, but these two are not interoperable to each other, at the time it will be a difficult one. So that interface between these two models, whatever we are developing, to be done carefully, so that well-defined modules interfaces are required in the incremental model or incremental process model. These are the advantages and the process activities whatever we are going to have in the classical waterfall model, as well as in the iterative waterfall model, and then in the incremental model. All the models are very important question for 8 or 7 marks in your examination point of view. It's all about my today's session. I hope you all enjoyed, and you understood all my concepts whatever I have discussed in my session. So in my coming session, we'll see about the spiral model along with prototyping model. Then we'll see what Big Bang model is all about in my coming session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.